Alright, example 7. Let's go ahead and see if we can find all the zeros if they tell us one complex zero. So we know right away that x minus 1 plus 3i is a 0. Because of those conjugate pairs, we also know that x minus 1 minus 3i is another one. So if we go ahead and multiply this all the way out, and I'm going to distribute first. If we multiply this whole thing together, we're going to be well on our way to finding all of our zeros. So I'm going to use the box method to make sure I multiply everything, just to keep myself organized here. Alright, so I've got x squared minus x minus 3ix. I've got negative x plus 1 and 3i. We've got 3ix. We've got negative 3i. And here at the end we've got negative 9i squared, which is the same thing as saying positive 9. So if we were to clean this up, let's cancel where we can. Nope, sorry. That still is okay, but these two cancel. And what do we have here? We've got x squared minus 2x plus 10. Alright, so we know that that divides out. So what are we going to use? We're going to use long division to divide all the way down. X squared minus 2x plus 10 goes into the huge polynomial. Minus 3x cubed plus 6x squared plus 2x minus 60. Here we go. X squared goes into x to the fourth. X squared times. If we subtract down, we get negative x cubed minus 4x squared. We'll bring down the 2x. And now x cubed divided by x squared is minus x. And so we've got negative x cubed plus 2x squared minus 10x. If we subtract down, we get negative 6x squared. And we get 12x. We'll bring down the 60. And we'll divide again, we get negative 6. And this should work out because we said these are zeros, so they should factor away. And yes, they do. No remainder. So here we go. We've got x squared minus x minus 6. Thankfully, that does factor. We'd have x minus 3 and x plus 2. So we now have all of our zeros. 1 plus 3i, 1 minus 3i, 3, and negative 2. Alright, we have 4 zeros. Let's go ahead and check to make sure that we have enough. X to the fourth, and so we do have all of our zeros. Alright, see if you can knock this out of the park for problem 55. Alright, we know that we've got x minus 2i and x plus 2i. So if we FOIL this out, x squared minus 4i squared, otherwise known as x squared plus 4. We know that goes in, so we use long division. X squared plus 4 into the entire polynomial. And let's go ahead and divide this out. We get x and that's 0x squared here as a placeholder plus 4x. Those go away. We'll have negative x squared plus 0x minus 4. And so that's going to be minus 1. We'll have negative x squared. And we'll have minus 4. So we get 0. So we know that we also have x minus 1 So we now have all of our zeros. 2i, negative 2i, and positive 1.